Hi, good afternoon, everyone. Thank you all for coming together for this talk on blockchain. If you look into that particular, this blockchain as a technology has been very popular in the last 10 years. Okay. In fact, so and so that blockchain is confused as a Bitcoin itself. Okay. So that is one of the power of the application of Bitcoin as such. But if you look into that particular as such, okay, so one of the major particular, this is all of everybody can build applications based on blockchain. For that particular this, there is an open source platform which is known as a hyperledger, for which essentially the contribution has come from IBM, Intel, SAP, and others people also. So in that particular this, it is important for us to understand what are all the possible applications, how do we go ahead, what are the nuances that are essentially involved in this particular technology. So to speak on that particular this technology, we have invited Sri Ramaguru, who essentially has got immense experience in this particular field. So Ramaguru, thank you very much for being a part of this webinar. And in fact, I would now request Professor Shilpa Patil to introduce formally Mr. Ramaguru. So over to you, Shilpa ji.
Yes, thank you, sir. Good afternoon, everyone. I'm Professor Shilpa Patil from CSE Department. It is a pleasure for me to introduce our speaker today, Mr. Ramaguru Radhakrishnan. Mr. Ramaguru Radhakrishnan is a cross-domain independent researcher, numismatist, philatist, trainer, and coach. He is from Metropolitan Coimbatore. He completed BTech Information Technology from Ramaguru College of Technology in 2011. He has around 5 years of industry experience as a test automation engineer for automotive infotainment units at Robert Bosch Engineering and Business Solutions Limited, Coimbatore, and Herman International, Bangalore. He has completed his master's in cybersecurity from Amrita Vishwavidyapeetham in 2019 and started working in cybersecurity and blockchain technology. He worked with Ensurity Technologies Private Limited, Hyderabad, as a lead blockchain engineer around 1.5 years before joining Amrita Vishwavidyapeetham as a research associate in Jan 2020. He is also the founder of Kanavu Public Charitable Trust, Kuppai, working towards education and environmental awareness. He has been training and teaching students through this Aksharam Training Academy. He is also the founder of NumChain Open Initiative Research Lab, working towards blockchain for social applications. His areas of interests and hobbies include blogging, teaching, collection of coins, stamps and postcards, research, recycling, sustainable management, software testing, cybersecurity, and blockchain. He was awarded the Cameron Best Outgoing Student of the batch 2007 and 11 by Ramaguru College of Technology, Coimbatore. He was also awarded Best Outgoing Student of the Department of IT, KCT College. He has published 2 papers, namely Blockchain for the Internet of Vehicles and Blockchain-Based Waste Management. We welcome you on behalf of East Point College of Engineering, sir. Over to you, sir.
Thank you so much, ma'am, and thank you so much, sir, for the introduction and giving me this opportunity to present my knowledge on blockchain technology. So let me share my screen. Maybe one of you can confirm if it is visible. Is it visible, ma'am? Is it visible? Can one of you confirm, please? Hello? Yeah. Okay. So yeah, can one of you confirm whether my audio is clear, audible, please? Because I hear total silence. So maybe one of you please confirm whether my
Yes,
screen is.
Yes, sir.
Yeah,
The screen is on share and your voice is audible to everybody.
yeah, thank you, sir. Thank you, sir. So yeah, let's get started. So yeah, quickly, considering the time, I'm not going to ask any one of you to respond. What do you see? But by looking at this image, you can understand this person. One person is telling it is 6, the other person is telling it is 9. So if you look it from the person who's seeing, from their point of view, whatever they are claiming is correct. But for the other person, it might look wrong or sometimes even absurd also. Okay. So whatever I am going to share is my certain things are, yeah, it's well agreed terms or topics, but some things are my own point of view. So there could be a difference in opinion for some of you who already know what is blockchain. So if there is something like that, I would be happy to discuss, or I'll be happy to know that view also. So this is that. So with this, I think I would like to start the session. So it is just only how you look at a particular thing, and maybe from your point of view, it will be correct. It's only that we have to look it from the other person's eye. So I would request all of you to keep your mind open, listen and receive what I tell. Then later you can analyze it with what you know and then decide. Okay. So please be open throughout the session. And if there are any doubts, you can stop me at any point of time and ask me. Okay, let's quickly get into what is blockchain. Okay. So blockchain, if you look, there are 2 ways in which you can look what is blockchain. One as a technology and one as a data structure. Okay, so blockchain in a simple term is nothing but a data structure which is very much similar to what is like a linked list, right? So if you know what is a linked list is nothing but a linear data structure. Like as you see, it is linear and it is a data structure where a data is getting stored, right? And in linked list, the items or each item in the list is not stored in continuous memory location. It is stored at different locations, and each of those things are connected by a pointer, memory pointer, right? So if you look at this, the data is 10 and the next data is in the location memory address 4900, and that data is nothing but 15. The next location is 5000. So similarly, the data is 5, the next location is 3000, and for the last one it will be null. So if you look at a linked list, it is a list that is continuously linked by the memory pointers, right? So the same thing we can apply to a blockchain also. Here, if you look at a linked list, the list contain 2 components. One is the data, the other part is the pointer to the next list, right? 10 is the data, 4900 is a pointer to the memory where the next data is available, right? So almost similar is what we can, in simple term, we can call it as blockchain. There is a block and each block is chained. If you look at it, is almost similar. There is a block, here it is a list, and each list is linked. That is why it is called as linked list. There is a block and each block is chained together. That is why it is called blockchain. So in a way, both linked list and a blockchain is nothing but a linear data structure. Okay, here there is a data linked to next data through a pointer. In blockchain, there is a block, there is another block. Both of these blocks are connected cryptographically through a cryptographic hash function. That's all. So this is one way of looking what is a blockchain. Hope I think it is clear. So blockchain is nothing but a data structure which is very much similar to linked list, where each block contains the data, or in other words, we can call it as a transaction. And each of these blocks are linked to the another block cryptographically, and that cryptographic primitive is nothing but hash value. So this is one way. What is the second way? The complete technology. The data structure alone is something reside in the memory, or that is something residing within a file system. But one other way to look blockchain is as a blockchain technology. The complete architecture, the complete computation, the wallet, all those network related things. So the other way to look is as a complete technology. So blockchain technology is nothing but a decentralized computation. Please understand, if you understand this definition, that itself is more than enough to know what is a blockchain, what are the advantages of blockchain, how blockchain works, where you should use a blockchain. All these things can be understood from just this definition. Blockchain is nothing but a decentralized computation. Computation is not done by one central system. It is decentralized. Distributed ledger platform. The data is not stored in one central server, but it is available to all the computers or nodes that is part of the network. So the data is distributed and the computation is decentralized. For what? To store the transactions immutably. To store the transactions immutably. Okay, for why is this data distributed to all the nodes? So that anyone can verify this data effectively and efficiently. And blockchain stores the data immutably because blockchain is append only ledger. You can only add a data into the blockchain. You can never delete or edit a data in the blockchain. Ideally, you will not be able to edit or delete anything. You can only add it. So this is what is called blockchain, the complete technology that makes this work. So it is decentralized computation, distributed ledger, and immutably store. Why immutably store is to verify this efficiently. And all these things happen in a excuse me. And all these things happen through something called as rational decision making process, which is nothing but consensus. Okay, so this is the other way to look what is a blockchain. One is from a data structure perspective, another is from the complete technology perspective. Okay, so now coming back to this again. So here if you look, the data could be anything. It could be one transaction or could be a couple of transactions, right? Just like how in linked list, the last list value, the address will be null because it is the last. So it is not pointing to any other data. So it is null. Similarly, in blockchain, the first block will not be pointing to any previous block. So the previous hash value will be 0. Now, if you look, this is not any hashing value. This is some hash that for a identification purpose I have given. So let us take for this particular block, which is in blue color, the hash value is going to be AX49S. Now, this is referred here. And this hash value is the connecting bridge between the block 1 and the block 2. You look here, for block 2, the hash value is F9D10. Can you look? That is available as a data in block 3. So this is the connecting bridge. Now, If you change something in block 1, what will happen? The hash value will change. Just because this hash value is getting changed, this hash value will also change because there is a link. And since the content is changed, this hash value will change. And this will get propagated to all other blocks. That is why we say blockchain is immutable. Why? The key property of a cryptographic hash function is even for a very small change, the cryptographic hash will change tremendously. So even if you make one space here, this hash value will change, which will in turn make all the blocks invalid. So that is why we say you cannot edit or delete a block in a blockchain because it is cryptographically connected through the hash value. And the reason why hash value is used is hash value, the key property of any hashing algorithm is something called avalanche effect, which is a small change in the input will change the output drastically. So now you would have got at least what roughly is a blockchain. Now let us understand why this hype, why everyone around, not just in India, but around the globe are trying to fit blockchain into one or the other use case. So what are the biggest advantages of adapting this technology or at least even learning this technology? So there are 4 important characteristics, we can say, or features or advantages, we can call it in any way. This you will understand it even from the definition. Blockchain is immutable, which means whatever data that gets into the blockchain is always there in the blockchain because it is tamper proof. No one can modify it. Next, even if couple of the systems which is hosting the data is crashed or it is destroyed, there are other systems which still have these data, so they can take care of the computation, just like a backup server in a centralized system. In decentralized system, even if certain systems cannot do the computation, other systems which are part of the network can do the computation work. So decentralization is one of the biggest advantage. Third one is transparent. Decentralization, the computation by any computer is possible only because all the computer have the data. That is because the data is distributed to all the nodes in the network, which is transparency. And to achieve all these things, we need something called as consensus. Because if there are 100 nodes in a network, these 100 nodes are operating in a similar fashion like internet. They don't know to whom they are talking to. They don't know the authenticity of the other node in the network. So you should somehow trust the decision that is given by other nodes in the network. And you should be able to decide based on that decision. So this decision and trust process in a blockchain is achieved through something called as consensus algorithm. So these are the 4 important characteristics of a blockchain: immutability, decentralization, transparency, and achieving the trust through consensus algorithm. So these are the 4 important characteristics. Now, if you look at the history, right, it is always important to know the history, how it has evolved over a period of time. Okay, so just like for computer, we have first generation till 5th generation, which I think all of us would have studied in our school computer science. Blockchain, it's only 10 years, right? It was almost 11 years old. 2009, January 3rd was the day in which the first block of Bitcoin was mined. And Bitcoin is the first application that was built on top of blockchain. Or in other words, Bitcoin introduced blockchain to the world. And that happened in Jan 3rd, 2009. So we are almost in the 11th year of blockchain, we can say. But already we are into 5th generation. So if you look at this, I'm not going to get so much deep into that. Just like how our computer generation evolved from a very small computation from vacuum tubes to artificial intelligence today. So Bitcoin was the first application that was developed on top of blockchain, which was only a cryptocurrency based system. So any system that is based on cryptocurrency only, that we call it as a blockchain system. Blockchain 2.0 is nothing but a cryptocurrency based system, but capable of allowing the users to write some user defined applications on top of it. Such applications are called blockchain 2.0. One example is Ethereum blockchain. Blockchain 3.0 are enterprise oriented blockchain, where there is no need for any cryptocurrency, but it is only application based, completely application based, mostly private and enterprise level applications. Such generations of blockchain are called blockchain 3.0. One example is Hyperledger projects, and Hyperledger project contain lot of applications like Hyperledger Fabric, Hyperledger Indy. There are n number of applications within that. Blockchain 4.0 is something like, you need not know the technicalities behind. You need not know what is a cryptographic hash function. You need not know what are the other different things that are part of a blockchain. But you can go to some website, give few parameters, and quickly you will be able to create a application on top of blockchain. This is something like for quick develop, like for example, web applications without knowing HTML, quickly you can develop a web page, right? So such kind of applications are coming out. So such kind of blockchains are called 4.0. But there is no clarity, because there is no clear definition, or there is no clarity that is available both for 4.0 and 5.0. There are some websites claiming that their application is blockchain 4.0, their application is blockchain 5.0. So it is only for information sake I have given 4.0 and 5.0 here, but there is no very concrete information what exactly 4.0, what exactly is 5.0. It is still not clear. But the first three generations are kind of very clear. Cryptocurrency based only, cryptocurrency based but user level application. Third is only application based. So these are from generation point of view. If you look at from type point of view, there are two major types. Now there are a number of types people claim, but ideally there are two types. One is permissionless. Permissionless is nothing but it is open, it is public. You can just go to the website of the particular blockchain, download their client. You are already part of their network. You can go to bitcoin.org or you can go to ethereum.org, download their client, which is, they call it as wallet. Okay, you download that. Once you download it and install it, you are part of Bitcoin network or you are part of Ethereum network. You need not give any proof. You need not give your Aadhaar card, PAN card, nothing is needed. You need not reveal your identity. You need not tell your name. It is open and it is public. Anyone who has installed the wallet or installed their client have access to the blockchain. You can see all the transactions that has happened right from 2009 till today. In case of Ethereum, right from 2015 till today, you can see all the transaction. There is no restriction like only this person can see this transaction. So such a system where it is open and public, anyone can join without any permission. Such a blockchain system is called permissionless blockchain. And examples are Bitcoin and Ethereum. Okay. The other system is permissioned, where you need to reveal your identity. You need to tell, I am Ramaguru, I am Venkatesh, I am Sundar, I am Anita. You have to declare your identity and you should also declare your role. I am Ramaguru, faculty. I am Anita, student. I am Venkat, HOD. So based on the role, what they can do in the blockchain is decided. So such a blockchain is called permissioned. So there is a permission on who can access the blockchain, who can become part of the blockchain, who can do what actions on the blockchain. So such a blockchain is called permissioned. But this term will be used interchangeably. Some people just used closed blockchain, which means it is permissioned. Some people use open and public, which means it is permissionless. Okay, and the example is Hyperledger. So now why people wanted permissioned is, you take any company, right? You take a company like Flipkart, you take a company like Amazon. Okay, they do all these big billion day sale, right? And all these prices, the price that they quote telling that it is you have to purchase a particular item with this time period, so that even a camera you can buy for 5 rupees, something like that happens, right? It is all based on some algorithm that automatically runs. Assume that if this algorithm is if it is stored in a blockchain, that will be public. So what will happen? What you claim as a business secret or what you claim as a trade secret is gone. Now Flipkart's algorithm or Flipkart's secret can be seen by Amazon and they can manipulate it accordingly. So there will be no fair play. So enterprises and big companies don't want all the data to be publicly available. They don't want all of their code or all of their data to be accessible by anyone. So they wanted a different system where only certain people, based on the access, they should be able to do something. That gave the blockchain 3.0, which is permissioned. So blockchain 1.0 and 2.0 are permissionless. Blockchain 3.0 came because they wanted a enterprise level application, which is a permissioned level blockchain. Okay. So these are the two major types. But now there is something called as private permissioned. All those things are there. But on a simplicity, you just remember permissionless blockchain and a permissioned blockchain. Quickly, let us understand. So how difficult it is. If to make things very, very simple, if you look at or if you do a comparison, nothing is going to change much. For people who are going to implement, yes, it is going to be a bigger headache. But from a common man point of view or from a very simplistic point of view, it should look very simple. There is a web page, right? Assume this is your browser. There is a web page which is created based on HTML, CSS, and JavaScript, right? It could be any JavaScript, right? And this is what runs in your browser, right? In a centralized system, what happens? In a centralized system, when you open a browser, you type www.google.com, www.eastpointcollege.org. Okay. And since it is HTTP, it knows the port number is 80. If it is HTTPS, it is 443. So it is automatically known to your browser. And there is different things like the ARP protocol and DNS, which automatically tells how to contact the server. So using HTTP protocol or whatever it is, they go to the centralized server. It is resolved to a particular IP address and it goes to that system, access the files, and it displays into your browser. And if there are data, some data that is stored, that is available in the database that is available in the same server. It could be a MySQL database, it could be a MongoDB, or it could be any Oracle, it could be any database, right? So it is there. So what happens if you move it to a blockchain system? Nothing is going to change. You still will have a website, and still that website could be in the same centralized system. And you will still use the same HTTP API. Only thing is that the database that was there in a central system will now go into blockchain. So now this data that was in a single system is now stored in a blockchain, and that blockchain could be storing all your data. So your data is distributed and no one can manipulate your data. Only your front end is there in the centralized system. Otherwise, nothing is changed. The database is now moved into the blockchain. And just like how you have a query language to query the database, for a blockchain, you write the application or you query the blockchain through something called as smart contract using any programming language. So this is smart contract is not exactly same as a query language, but in a way we can equate it for understanding purpose. So now if you look, blockchain is nothing but a database, but that database is distributed. That's all. This is a third way to look at a blockchain. Blockchain is nothing. Instead of a central database, you keep it as a decentralized database, but it is doing more than what a database would do. So this is what, if you quickly relate and see what happens between a centralized internet and a decentralized internet, just the thing is that the data is moved into blockchain, and whatever from the user point of view, for him nothing is changed. He will still use his mobile app, or still he will use his browser, computer browser, to access the data. Only the back end is going to change. Front end is not going to do any change for the user. So now let us understand why someone wants a blockchain, right? It is always important to know what. Now at least you know what, right? What is a blockchain? You might have at least a rough idea. Now, why is that needed? I used a term here, right? Decentralized database, right? There is something already called as decentralized database. In case if you have studied, there are different types of databases, right? So there is already something called as a distributed databases and all, right? Then why should someone invent something new? So if you look, there are some problems that was existing for quite some time, right? If you look at from Bitcoin perspective, because someone had some problem and they wanted a solution, they introduced that solution. That was Bitcoin. And there, to address that problem, the technology used was called blockchain. And we took that and we tried adapting it to the different thing. So we should understand what would have gone into the minds of the creator of Bitcoin, right? What all problems he thought and what is that he wanted to solve and how did he solve. If you can understand this, it is the same for all other applications or use cases, or it is the same mentality in which the other developers could also think. Okay, there are quickly few problems. One is ledger. So this is a traditional ledger, right? Even today, some of these ledgers could be available in some form. Okay, let us say even in your college, if there is a multiple entry points to your college, the security will ask the entrant to write their name, the time, whom they want to meet, address, if they are going in a vehicle name. So that is a ledger. So a ledger is nothing but a series of transactions. We can call it as a series of transactions. And a transaction is nothing but a record. Like I'm coming to your college, I'm writing number 22, Ramaguru Radhakrishnan, 2:30 p.m. for a webinar, Department of CSE, and I'm coming in my vehicle. When I enter this data into the physical ledger, that record is called as a transaction. And this book can have multiple transactions because in a day, lot of people can come and go, right? And this could be there for a financial transaction also. If you take your passbook, that is a ledger. Passbook is nothing but a ledger. You will have a date, you will have a description, UPI transaction, and you will have a reference number, and you will know whether it is a credit or a debit. After which you know what is the current balance after the transaction. Now, what is a biggest disadvantage in maintaining a ledger is, normally, even if it is a very small organization or even if it is a very small transaction, there is no one ledger, there is always a multiple ledger, right? If you want to prove a truth, if you want to prove something, you need multiple ledgers. If you remember any of older movies, any Tamil, Telugu, Kannada movies of 1990s, you will see the hero telling that, hey, today I will come late because I have auditing in my office, right? And they will be all doing all these things. And this auditing is one thing. What is auditing? Auditing is nothing but someone from an external organization will come and check whether everything is properly accounted, right? And that they will check this ledger. And even in that time, they will only do sample checking. They will not check everything extensively. Why? Because it is extremely difficult. Take a use case. Your college, Department of CSE is buying 5 computers. Okay. And this 5 computers is coming in a particular vehicle. So in the entry, the checkpoint in the gate, they would have wrote this vehicle is going to Department of CSE and they are carrying some computers to department. And once it is received to your department, if there is an asset manager, he will also note it down. There are 5 computers and he will paste a sticker in the computer telling that EP/CSE/monitor/01. Some number is given. And your department maintains this ledger, right? Now, if an auditing comes, they have to refer multiple ledgers to check something. So this is one bigger headache. Even for one small transaction, this is a bigger headache. Blockchain, how it solves? Since blockchain is a distributed and a decentralized environment, all the data is available to everyone. And there is only one chain, which means there is only one ledger that is available. So all the transactions are available in the same ledger, and all the transactions are visible to all the people because it is distributed and decentralized. So this was one problem that was there in traditional accounting or traditional ledger, and this is how blockchain solved. It was there with one person, or you need multiple ledgers to prove a truth. But in blockchain, since it is distributed and decentralized, there is only one ledger. Blockchain acts as a single source of truth. So this is how one problem was solved. Now, the next one, it is similar to accounting only. There is something called as double spending. Double spending is nothing but it's a major flaw in a digital transaction where the same digital cash, you can spend it twice. This is a bug in a digital transaction, and this we will not be able to fix it in a traditional system. Still, it is possible, but blockchain solved it. Why? Again, because the centralization is stopped. Blockchain gave the data to everyone, so it is stopped. If I want to give it as a simple example, let us take I am asking one of my friend to buy me 2 samosas. Okay, and my friend knows that I have a 50 rupees in my packet. Okay, my friend knows that I have a 50 rupees. I am asking that guy, okay, can you please get me 2 samosas? He knows that I have 50 rupees. So he will think, okay, let me get the samosa. While giving it, I will get the money from Ramaguru. Okay, now he goes. One of my other friend comes after that. Now I am telling, hey, can you get me 1 maza? And this person also now knows I have 50 rupees. So what he will think? He will go and buy maza for me, thinking that I have 50 rupees, I will pay him. Now when both of these people come, I have made them to purchase, or I have made them to deliver me 2 products, 2 samosas and 1 maza, but for the same 50 rupee. Okay, so this in a way we can call it as a double spending, and this is there in present day digital transaction system. That is why normally what happens if some transaction fails, they take 7 or 8 days for the transaction to revert. This is one of the reasons. There are so many other reasons. So this is one problem. But if you take blockchain, what happens? Since this information is known to everyone, as soon as I tell my friend, hey, can you get me 2 samosas? This information is known to everyone in the network. Now, when I go and tell my other friend, can you buy a samosa? He will tell, hey, do you have money? Because you already told that guy to buy samosa. Why? Because the information is immediately given to everyone. I cannot double spend it. But whereas in the first case, I can double spend it because a single bank maintains the ledger. The transactions of State Bank is with State Bank. The transactions of IOB is with IOB. So each bank hold their own data. So because of non-accessibility to that data, there could be a reason that double spending is possible. But whereas in a blockchain environment, it is not possible because the data is available to everyone. And this example I gave is for you to understand and correlate what a double spending could mean. It is not exactly what is double spending. It is an example for you to understand what is double spending. So this was the second major problem, and until Bitcoin or blockchain came, this problem was not at all solved. Bitcoin or blockchain solved this big issue first time after its introduction. So this is one great problem that was solved. So now quickly, let us see what are the building blocks of a blockchain. Like I want to learn blockchain, or I just want to know what are the things that makes a blockchain, because the problems that was solved are very good. But did the person who created Bitcoin, did he find something new? No, he did not find anything new. The major things that was used to create a blockchain is distributed computing. This person was very much aware of how to use distributed computing and how to use consensus algorithm. Next, he was very sure of what is a public key cryptography. So considering the time, I am skipping this. I am not going to explain what is an encryption and decryption or a digital signature algorithm. But in public key cryptography, these are the two things that you should know to learn blockchain. What is an encryption and decryption? Encryption and decryption is nothing but a method, a cryptographic method through which you achieve confidentiality. What is a digital signature? Digital signature is again a cryptographic method to achieve integrity and ownership, right? So this is one other important thing that is used in blockchain. The third important thing, which is very simple, is cryptographic hash. But that is the one that carries the complete blockchain. Cryptographic hash is very simple. You give a big, even if you give Ramaguru, if you give a 1 KB file or a 10 MB picture or a 2 GB movie, the hash value is going to be same. So cryptographic hash functions are one of the important building blocks, not of just of blockchain, but even for the modern cryptography and cyber security. Without cryptographic hash, I think we will not be able to do anything in something to do with blockchain or cyber security. So you should know what is a cryptographic hash function, the advantages of cryptographic hash function. You should know what is a public key cryptography, and even in that, only what is the use of encryption and decryption, how a digital signature algorithm basically works. And third is the challenges that you will see in a distributed computing and how consensus is solving. So these are the three important things that basically you should know to understand or to learn blockchain technology. Is there any doubt so far? Okay, taking that silence as no doubts. So Bitcoin, okay, Bitcoin, and if you look today, this is the rate of one Bitcoin today afternoon. So I updated this today afternoon. So today afternoon, one Bitcoin is nothing but how much? Around 12 lakhs, right? So Bitcoin was the first application that was developed on top of blockchain, which was through a white paper titled Bitcoin, a peer-to-peer electronic cash system. And it is created something called as cryptocurrency. Okay. And this person who created this is called Satoshi Nakamoto. We are not sure whether this is one person or a group of person, but a person with the pseudonym Satoshi Nakamoto claimed to have created this Bitcoin. And as I told, 2009, Jan 3rd was the time when this Bitcoin first block was mined. And today we are almost 11 years into Bitcoin. So if you look at Bitcoin, some quick statistics, okay. The total number of Bitcoins that can exist over its lifetime is 21 million Bitcoins. Okay. There can be 21 million Bitcoins that can ever be created. And that 21 million Bitcoin can be created. This 21 million will be reached in the year 2140. So only in the year 2140, Bitcoin will reach the maximum value, that is 21 million. Okay. And for each block, Bitcoin takes 10 minutes. For each block, Bitcoin take 10 minutes. So normally how it works, if you look, let us take, there are 10 people in a Bitcoin network. Okay. And as I told, it is a open and a public blockchain. So anyone can download Bitcoin wallet and they can become a part of the Bitcoin network. Terms and conditions apply. Okay. It will take some computational storage power from your computer. After that, yes, you are part of the Bitcoin network. Once you are part of the Bitcoin network, assume you do some transaction. Like you say, I do a transaction to one person A, and there is a person B do a transaction to C. There is one other person D does a transaction to E. All these transactions will be first validated in the Bitcoin network. Okay. Once it is sure these transactions are genuine transactions, it will be put into something called as memory pool. Okay. It will be put into something called as memory pool. Once this 10 minutes is reached, what will happen? Each node will take the transactions from the memory pool in such a way that the size of the block is not greater than 1 MB. Assume that now I told 3 transactions, right? One from me to A, B to C, D to E. So there are 3 transactions that has happened in the last 10 minutes. But only 2 transactions can fit into the block because these 2 transactions is almost reaching 1 MB. So though 3 transactions have been successfully validated and put it into the memory pool, only 2 transactions will be put into the block because there is a size restriction that in Bitcoin, one block can maximum contain transactions of size up to 1 MB. Now, this block is created and it is given for mining. This mining is nothing but validating whether the block is correct or not, whether it is a genuine block or not. That validation process is called mining because if a particular node finishes the validation first, telling that yes, this particular block is valid, and if I am the first person to complete that, this block will get added into the blockchain. And since I have used my computation power to do this, I will get a reward from the network, Bitcoin network. And that reward is how blockchain gets the money. Now, if there is a block that is getting added today in Bitcoin, 6.25 Bitcoins are newly created and it is given as a reward to the person who validated the block. And since there is a money that is getting generated, we call that process as mining. Otherwise, if you look at in a technical term, it is just that a particular node is verifying whether a block is a genuine block, whether a block is good enough to be added into the blockchain. So it is actually a block validation process. But in addition to the block validation, after the successful validation, new cryptocurrency is created and that is given as an incentive to the validator. We call that process as mining. That's all. Okay. And as on today, the Bitcoin block reward is 6.25 and that get reduced for every 4 years. So now, consensus. I don't think we will have enough time to explain what is a proof of work because this itself need over half an hour explanation. So I'm just going to tell very on a surface level. Okay, proof of work is the consensus algorithm that is used in Bitcoin network. So proof of work, as the name suggests, you have to provide a proof to the network telling that yes, I am the person who have validated this block and this validation is correct. So that has to be given as a proof and that proof should be available within the block itself. It should not be any additional attachment. Once you give this proof, the other nodes will verify whether you have actually validated the particular block. If other nodes find it correct, they will add that particular block into the blockchain in their node. Okay, so proof of work is the consensus algorithm, or is the method through which Bitcoin validates a particular block can be added into the blockchain or not. Okay. Next, the second thing is that the proof of work should be very hard for the miner. Why? Because he is getting a reward, right? Assume today I successfully mine a block. I will get 6.25 Bitcoins as a reward for mining, right? And I showed 1 Bitcoin is 12 lakhs. So assume how much I will get. 6 into 12 lakhs, almost 7. I will get that much. 6 into 12 lakhs. So it shouldn't be easy, right? If it is easy, anyone can do it, right? So the mining process should be very difficult. Why? Because we are providing some reward. So only a person who works genuinely should get it. Second, if it is very easy, what will do? I will also compute, you will also compute, someone will also compute. And after computation, what we will do? All of us will send that block in the network for validation. What will happen? The network will become congested. Why? Because it was easy, everyone would do. And since everyone have done their validation, they will send it for the addition in the blockchain to the other nodes. This will cause congestion, which will in turn end up in denial of service. It could either be done purposefully or it could be unknowingly also, but it will result in denial of service because of network congestion. So it should be hard to compute, but it should be easy to verify. So such kind of a puzzle is what given as a proof of work. Okay, but this is not again something that is very new. There was a particular work by someone called Adam Back. That person is still alive in 1997, which is called Hashcash. Okay, so based on that work, few changes were done, and that was successfully. Now we are using it as proof of work. So proof of work is the consensus algorithm that is being used in Bitcoin network for block validation, or we can call for mining. Okay. Now, this is only a cryptocurrency based network, right? You can only create a currency and you can do a transaction. So what are the disadvantages that people saw? So disadvantage was that you can do a larger transaction and it will end up in 10 minutes. Okay. The transaction fee could be less. Okay. But micro transactions are not possible. Like in UPI, you can send someone 2 rupees. You can tell I bought 2 rupees from you. You can send 2 rupees in UPI. There is no transaction fee for 2 rupees. You can even send 2000 rupees also. But in Bitcoin, micro transactions are not possible. One. Second, the timing is very large. In UPI or in Paytm, it will take a few seconds for you to send a transaction. But if you're going to use Bitcoin, it will still take 10 minutes. Even if you send 1 rupee, also 10 minutes. 2000 rupee, also 10 minutes. So there is no importance given to the transaction content, but it is always 10 minutes. One. Second, Bitcoin is ideally supposed to be a cryptocurrency. But do you think it is acting like a currency? No. That is one problem in India, right? In India, if you look, initially, the government of India, or you take Reserve Bank of India, they didn't do anything. They told, yeah, we are not stopping anyone from using Bitcoin, but if something happens, it is the user's responsibility. We will not be responsible. Then later, government of India banned usage of Bitcoin. Holding, transaction, mining, trading, everything was banned. March 2020, the ban was lifted. Okay, just before this corona lockdown. Okay, now the problem in India, this is why, this is what is the one major problem that cryptocurrency or even blockchain faces. In India, Reserve Bank of India is claiming that, yeah, we are the, Reserve Bank of India could claim that, yeah, we are the legal authority to do something to do with currency, right? Because currency in India is managed by RBI, or in any country it is handled by the central bank. For India, RBI is the central bank. Okay. In India, anything to do with stocks and bonds is handled by an organization called SEBI, Stock Exchanges Board of India. Okay. Cryptocurrency, the name, it is currency. Bitcoin, it is meaning currency. Okay. But is it behaving like a currency? No. When Bitcoin was introduced, one Bitcoin was few rupees, right? There is one famous transaction called pizza transaction, where 2 pizzas were bought for 10,000 Bitcoins in 2010, I guess. 2 pizzas were bought for 10,000 Bitcoins, 2 pizzas, 10,000 Bitcoins. And today, one Bitcoin is 12 lakh. You can buy one pizza shop itself, right? This is not how currency will grow. So Bitcoin is, though the name looks like a currency, or the intention behind creating this was for use like a currency, but it is not behaving like a currency. It is behaving like a stock only. Based on the demand, it is getting, the value is getting increased. So this is one major problem. Okay. So people wanted a next generation of blockchain or a different blockchain where it is not just cryptocurrency based, but they can create some applications on top of it also. Assume, anyway, this cryptocurrency is virtual. You are not going to print, or you are not going to issue like a coin, what you see, right? It is virtual currency, right? Cryptocurrencies are virtual currencies. So anyway, you are going to tell Ramaguru transferred 5 Bitcoins to Sandhya. Okay. And this is what is getting stored in the blockchain, right? And this is what is getting validated. So what people thought is, anyway, it is only a record, right? So instead of 5 Bitcoins, I can even tell Ramaguru got MTech cybersecurity degree. This transaction can be stored, right? And this is immutable, right? Ramaguru sold a house to Minu. This is a transaction, right? This can be stored in the blockchain, right? So what people thought was, blockchain has more potential. It could be used outside cryptocurrency also. So that thought gave something called Ethereum. Okay. So they created a next generation of blockchain. This thought was resulted in a new blockchain called Ethereum blockchain, which some people refer to as world computer. Okay. And Ethereum was created in 2015 by a person called Vitalik Buterin. Okay. He was working, he was part of Bitcoin community. So it is similar to Bitcoin. It has a cryptocurrency called Ether. It is again open and public. Anyone can access it. But it add one thing extra. It is also a smart contract platform. It also add something called as smart contract platform. What is a smart contract? As I told, no, just like how 2 people are involved in a currency transaction, in any transaction, 2 people are involved, right? If I want to sell a land, there is a seller, there is a buyer, but there is a third party. Who? Registrar office or a broker, right? Even in case of a financial transaction, I want to give you some money. but I need who? Bank. And I pay the bank some transaction fee. You take a DD, you have to pay a commission. You do a NEFT transfer or an IMPS transfer, you have to pay a transaction fee. Why? Because bank maintains that ledger, bank does the computation. Now, if you come to blockchain, what is one other advantage? You remove this third party completely out of the operation. I want to send the money, I can directly send it to you. And that is stored by all the people in the blockchain. And whoever does the computation work, they are getting paid some incentive. So whoever is getting paid is for their computation, which can be less than the bank. State Bank of India or any bank can charge some 20 rupees for a smaller transaction. Now, this blockchain network, if you are creating within your organization, you decide the transaction fee because the computation is done by your computer. And you also eliminate one third party. One bank is removed or one register office is removed. So smart contract is nothing but it is a self-executing computer program between two parties. But this is already there even in today banking system. There is something called as standing instruction, right? In bank. ECS, I think. It is called ECS. You can automatically transfer from your savings account to your loan account 3,000 rupees on 5th of every month. And this is self-executing based on the condition that 5th of every month is reached. Okay, and this is between two parties. So the self-executing between two parties is not what making the contract smart. It is getting executed on a blockchain, which is a distributed system. But still, the current day smart contracts are not smart or nor contracts, because they are not smart because it is again a simple program telling that if this, do this, if that, do this. So that is not smart. It is a simple if or else condition. And neither it is a contract, because contract, it is, if you take it as a contract, legally whether it is valid as per contracts law, no, it is not valid. Smart contracts are not legally considered as contracts. So smart contracts are neither smart nor contract, but it is called smart contracts, but maybe in the future it will become smart and it will be accepted in the court of law. So, but this is smart contract is a self-executing program. So now if I want to sell a land, what I can do? I can give the details of my land, put all the details of my land with the document. Okay. And that I can transfer it to you. And this will still happen in 10 minutes or so. But whereas if you go to a register office, it will take 1 week maybe for you to get the work completed. So for larger transactions, blockchain are good. But for micro transaction, it is not good. One. Second, blockchains are not only for cryptocurrency, because blockchain, in other word, is called as, it is called Internet of Value. The present day internet is called Internet of Information, right? You go to Google, you get everything. Blockchain is Internet of Value. If you have a value, you can transfer. It could be a currency like Bitcoin or anything, or it could be something like land. Land has a value, right? And even your MTech degree has a value, right? Because that is what is going to fetch you a job, or that is what is going to fetch you a loan from a bank. So that has a value. So this can be transacted on a blockchain without a need for a third party. Okay. And this idea of smart contract is also not new. Smart contract, the idea came into existence in 1997, but it was cleverly used by Vitalik Buterin in Ethereum. Okay. So this is what is smart contract. And Ethereum, it allows user, as an end user, you cannot go and write an application on top of Bitcoin, but you can write an application on top of Ethereum using the smart contract through any language like Java, Python, or Solidity. You can write a smart contract and deploy on top of it, and still it will work. You can sell milk on blockchain. You can sell coins on blockchain. You can sell dogs. You can adapt dogs. So such things are returned through smart contract. So this is second generation blockchain. And as I was telling, The biggest problem is there is no standard. You can define a blockchain in any way and still you can claim that is correct. Why? There is no standard organization. Bitcoin is open source, and all the things related to Bitcoin, the suggestions, the improvements, the issue, new features, or existing issues, bug fixes are all done by Bitcoin community. So there is a standard for Bitcoin, which is called Bitcoin Improvement Proposal, BIP. But if Bitcoin approves it, it becomes a standard and Bitcoin will implement. But other blockchains, it is up to them to implement or not. There are some standards of Bitcoin which others have not implemented. But there is one standard of Bitcoin which is called hierarchical deterministic wallet. That is implemented by all other blockchains, or that is at least adapted by all other blockchains. Similarly, Ethereum has a proposal called Ethereum Improvement Proposal. And once that is approved, it becomes ERC. Okay. So for tokens, there is a standard. For identity management, there is a standard in Ethereum. ERC 721 is token standard for non-fungible tokens in Ethereum. But this is only for Ethereum. Some other blockchains, let's say Hyperledger, can adapt it or they can ignore it. So there is no one single organization that does standardization for blockchain. You take mobile communication, right? There is IMT, International Mobile Telecommunication, something like that is there, right? But there is nothing like that for blockchain. So that is why all these confusions. What a particular term means, what a particular term will not mean. There is no clarity. But thank God, July 2020, at least for vocabulary, International Organization for Standardization came up with a ISO standard called 22739, which defines the terms in blockchain technology and DLT, distributed ledger technology. It is only the vocabulary, what are the terms and what those terms would mean. But again, some people will adapt ISO, some people will not adapt ISO. So if these confusions are kind of solved, then I think there is more future for better adaptation. So these are some of the Bitcoin standards, and still, things are here and there. It was not very clear. Now, quickly getting on to the applications. As I told initially, when blockchain was seen only as Bitcoin, and because it was money making also, people quickly forked Bitcoin and they created Litecoin. They quickly forked Bitcoin and people, whatever name they want, they gave. But not all cryptocurrencies succeeded. Only some cryptocurrencies which had some good applications or which had some meaningful changes and improvements sustained in this journey. Otherwise, remaining people have gone. And later, after Ethereum came, the applications moved out of cryptocurrency. It moved totally out of it. But if you look very in a simplistic term, blockchain by itself is very interdisciplinary. Blockchain, to know blockchain, you should know a lot of things. If you look at just considering only the two important domains, blockchain, computing, economics, right? These are the two important topics you take. You should know what is distributed computing to understand blockchain. You should know how a distributed consensus work. You should know advanced data structures, right? And you should know what is a digital cryptography. You should know what is digital cryptography, right? You should know what is encryption, decryption, what is integrity, what is digital signature algorithm, what is elliptical curve cryptography, right? What is RSA, all such things you should know. From economics point of view, you should know what is a contract, how two people negotiate a contract, how business happens, how things are ledgered, how value for a currency will grow, how supply chain works, how if you get a product from Flipkart, it moves from one place to another place, right? From the vendor to Flipkart warehouse, from Flipkart warehouse to the logistics people, from the logistic people through different locations, then it reaches your warehouse, then from there one person will comes and the final use. So supply chain. So you should have idea about all these domains. May not be in depth, but to understand blockchain or to understand a blockchain application or to adapt blockchain to your application, you should at least know all these things, or you should have at least people who know all these things. So blockchain by default itself is very interdisciplinary. Just because you are a good programmer, you cannot be a blockchain expert. You should know basic programming, you should know cryptography, you should know computing, you should know how currency works, how central bank works. Okay, all such different things you should know. So quickly, so these are the application. Of course, the first one all of you know, cryptocurrency, and there are Bitcoin, Litecoin, Dogecoin, n number of coins. The other applications are all very interesting. Where else you can use? Again, I'm going to my definition. Blockchain is suitable only if there are multiple people involved. If there are multiple people involved. Take, for example, you get 500 rupees from your father. Will your father ask you to sign some bond and all? Some document will your father ask you to sign? No, right? He will not even be worried. Why? Because he is not worried whether you are going to cheat him or not, or whether he is very confident that you will return this money. Or say you get the money from your friend. He is not going to ask few witness sign the document, because he is trusting you that you will return. You will not tell the day I got only 50 rupees, not 500. He is very sure about your integrity. So blockchain is more suitable when there is no trust. Okay, and the trust becomes an issue only when there are multiple people. If there are two people, at least we can say on a long term there could be a trust. But if there are multiple people, either because of the complexity of the application, you will not trust, or the people who are involved itself, you might doubt whether they could cheat, so you don't trust them. So when there are multiple people involved and you don't trust those people, then blockchain is more suitable. Otherwise, you can enter it in Excel sheet. I gave 200 rupees to Ramaguru. I gave 800 rupees to Vikram. Because you know that they won't cheat. And you are writing this for your own reference. So you can put that in Excel sheet. No need blockchain. Only if it is multiple people and you don't trust. One. This is one way you decide whether your application is suitable for blockchain adoption. Second, I want later auditability. I don't want multiple ledgers. I just want only one ledger to track all my transactions, and later for future reference, for auditability, I want, then you can go for blockchain. In that case, yes, you worry that if you put it in an Excel sheet, someone can manipulate. Then you can put it in blockchain, even though you trust the other person. You put it in blockchain. Why? Because you want one ledger for auditing, not multiple ledgers. So in that way, we can go. So you take all these applications, what I have listed, will involve multiple people and will be not having trust. You take e-governance. E-governance is nothing but you take the schemes, right? Pradhan Mantri's Ujjwala scheme, right? Where they issue subsidy for the LPG cylinders, right? Now it is done through Aadhaar-based payment system, right? That can be done through blockchain. So that is e-governance. You can issue community certificate, you can issue income certificate. All such things can be done on blockchain, right? Even for vehicle, now there is something called as Vahan, right? Parivahan, right? Government of India, Ministry of Transportation. That can be done on blockchain. So such kind of systems are more suitable. Why? Because there are multiple people involved. And in case of India, it is more suitable. Why? Because there are multiple ministries itself is involved. If you take vehicle, there is one local RTO who is involved, one person, the license holder is involved, then Ministry of Road Transport is involved. And again, for verification, again, police officers is involved. So a lot of people are involved. Next, you come to identity management. You can take Aadhaar and make it as a digital identity. You can issue Aadhaar card online, which will become an identity system, right? And this is one of the important application which many people are trying to take out from blockchain, identity management for self-sovereign identity. Okay. You should manage your own identity. Okay. And next is health record maintenance, right? You are getting treatment in a local hospital in Karnataka, say Bangalore or Bengaluru. Okay. Now, all these medical records are here. Let us say all these things are put into blockchain. Now, later you go to Japan on deputation for your work. These records can be accessible by the doctor in Japan because you can give access to that doctor all your medical records. Two advantage. You gave the access, one, and still the records will not be manipulated by the other doctor, or the other doctor cannot deny, no, I will not give this record. You should come back to me for the treatment. Otherwise, I will lose my money. So one doctor cannot restrict you from going to another doctor for second opinion or third opinion. Why? Because it is in the blockchain and you have the access as the owner because it is your medical record. So medical record maintenance, or in other words, health record maintenance, can be put onto blockchain because it can be given to other doctors. So one hospital or one doctor cannot deny you. Secondly, you have the control. The medical records, you have the control. But currently, in the present day medical system, your medical records are in the hospital system. If there is some data breach, all your medical records are at stake. You don't have the control. You have it as a hard copy in your file, but the digital copy is there in the hospital. It is not in your access. Third is digital rights management, copyright issues. Maybe for your music, for your videos, or for your artwork, that can be managed through blockchain. Then credentialing, as I told, you get a certificate, EC Council certified ethical hacker, CompTIA certified network administrator, Cisco certified something, right? All these things can be stored in the blockchain. And if you're going for a job, or if you're going for any higher studies, that particular higher study institution where you've gone, they can verify it in the blockchain. They need not even go and contact your previous college. So a lot of time will be reduced. Auditing becomes easy. Authenticity, integrity is all ensured, and still privacy is ensured because you should give access for them to access your certificate or your records. The last one is supply chain management, which is very, very important because blockchain, one biggest application what a lot of people are trying to use is supply chain management. Because supply chain management by default involves a lot of people. You have you take agricultural supply chain management. You have a farmer. You have a packaging industry. Okay, you take a farmer who is growing strawberry or mango. A farmer is there. Then, if they are getting organic certificate, this organic certifying authority is part of the blockchain. They are giving it to the packaging industry. Packaging industry is part of the blockchain. They are giving it to the transportation. They are also part of the blockchain. It is going to a store, cold storage or a warehouse. They are also part of the blockchain. Then it goes to the vendor like Walmart, Reliance Fresh. They are also part of the blockchain. Then as an end user, you buy the product, you are also part of the blockchain. You go scan the QR code, which is wrapped on the top of strawberry or that mango. You can see the complete, this particular strawberry was grown in this particular farm in Switzerland. Then from there, it was gone to this particular packaging house. From there, on this particular day, this particular time, it was shipped. It reached India. From Delhi, it was shipped to Chennai. From Chennai, it went to Nungambakam. In Nungambakam, there is one Walmart house. There, it is sold. You can see the complete transaction. And this has opened the door for a lot of things. What you can do? You can directly tell this particular strawberry is very good. And now the farmer is getting benefited, which is not there in today's system. If all the people review a particular strawberry from a particular farm is good, then automatically he is also getting a lot of business done on top of it. And secondly, you know where the food comes from and when it was grown. So this is one bigger application that blockchain is showing. Agricultural supply chain management, food supply chain management, pharmaceutical supply chain management, and any other, even the products that you purchase through Flipkart or Amazon, those are also supply chains only. So there are n number of applications that blockchain holds. Quickly, I would like to show one small application. It's very simple. I'll just so if you look at this, so this is one very simple application for a demo I created, or even I'm using it for some things. Okay, so this is a certificate issuer. Okay, you can issue a certificate on blockchain. Okay, like let us say I want to issue a certificate to one certificate I want to issue to your college. Okay, so East Point College of Engineering and Technology. Okay, designation I am just going to say Department of CSE. Okay, or Department of, I'll type fully, Department of Computer Science. Okay, institution again, I'll put this. And certificate ID. Okay, I'm just going to put NumChain webinar November 2020. Okay, and if your institution is part of blockchain, what I would do is I will give your institution's address. This is your wallet address. Okay, and now what I'm going to do is this certificate I'm going to create as a or a digital token. Okay, for that token, let us say I'm going to give a ID. Don't worry too much about the terms. Okay. Okay, so now, so let us say I'm going to issue this certificate. Okay, so now in blockchain, whenever you do a transaction, you have to pay a transaction fee. Why? Because this transaction that is going is stored in someone else's computer, and someone else is going to verify whether this transaction is valid or not. So the transaction fee that you pay will go as a incentive to them, which is similar to what you do in a normal transaction. When you pay from A to B in a state bank, right? You pay a transaction fee to State Bank, right? Because State Bank is processing your data and they are storing all the transaction, you are paying them. Here, I am paying it to the network, and network will pay it to the miner who mines this transaction. Okay. So as soon as I submit the transaction, I got my transaction ID. Okay. Just because I got the transaction ID in a normal way also, it doesn't mean that the transaction is successful. Now I have submitted the transaction. The transaction is now getting processed and it got confirmed. Okay. Now I can check the details of this. Okay, I can view this certificate. If someone wants to come and view, no, can they see? Can you see? I just gave the token ID. I can see the certificate detail. Oh, East Point College of Technology, designation, right? Institution, certificate ID, valid ID. All these things can you see? Now, if assume your college is going to issue a certificate like this, what is that you should carry? You should either carry this token ID or this token ID in form of a QR code to your company where you want to verify. What they can do, they can open the certification verification portal and just scan the QR code. Blockchain will automatically show the certificate. That's all. Now, the company has not contacted your college, but they have verified the certificate. Secondly, this certificate was put into blockchain by your college. So now there is no third party involved. The verification time has reduced. Now you cannot modify this. Your college cannot modify this. Your company cannot modify this. So immutability is achieved. Reduction is time is achieved. Third party is not available. And only if you give this token number, anyone will be able to access this details. So you are holding the right to give your this thing. This could be true for medical record. This token could, instead of certificate, here I can display my medical record. Here I can display my asset, how much houses, vehicles, jewels I own, right? So this is one simple application, very, very simple application that you can see on blockchain. I can even show you quickly. We have still have a few minutes. With this, I think we are done. So if you look here, so this is, can you see? So this is the transaction. The transaction was mined 2 minutes ago. And this is the contract, the smart contract I wrote to create the certificate. And this is the token ID I created. Okay. So I can see, this is the transaction fee that I paid. So I'll be able to see all these details, and the transaction is successful. So now this detail is stored in the blockchain. So anyone can go and check this in the blockchain. Anyone will be able to see this because Ethereum is public and open. So anyone who have access to this link, they will be able to see. So yeah.
Sir, there are some questions asked by the audience.
Yes,
I'll put it on the screen. You can answer them.
Yeah, sure, sir. So that's all. So that was what I wanted to share. The question, sir?
Guru, I think we do have a couple of questions from our students.
Why is
and faculty.
blockchain immature with respect to scalability, integration with legacy system? Why is blockchain immature? There are different reasons we can tell blockchain is immature, ma'am. Blockchain, still people say it is in its infancy stage. Though it is 11 years old, people still consider it is in infancy stage. It is because one is there is no standardization, as I told. People are not understanding it. Or you take people who are even working in the field of computer science, or people who are even into cyber security, they themselves are not aware of what is this blockchain is. Because as I told, it is interdisciplinary. Secondly, there is no standard. Third, people are even hesitant to learn what is this blockchain. One. And second, even people who implement and who are taking up this product, they are hesitant, thinking that how will someone understand blockchain? Even if I create a system in blockchain for certificate management, people think, Ramaguru, do you think will someone understand token ID? Ramaguru, do you think someone will understand this, that? They're asking all these things. One simple example what I normally give is, even a street vendor today is using Paytm. They don't know how QR code works. They don't know how all the technology behind Paytm works. But still a street vendor is using. It is only because of the awareness, the Paytm, the advertisement and awareness the Paytm people have given, it has reached everyone. So similarly, if the awareness on blockchain is reached to many people, automatically this immaturity, what is there today for blockchain, will automatically be solved. But if you ask it with respect to scalability, and one more thing was there. So if you ask how it is in terms of scalability and all, if you take scalability is one big issue. But again, there are some solutions that is coming. But even personally, what I feel from what I know is, it is only very few people are working on this. if there are other people who are experts in their own domain, if they are ready to learn blockchain, and if they can contribute, automatically this immaturity will be gone. This is what my personal opinion is. I don't know whether I understood your question correctly, but from what I understood, this is what I can tell, ma'am. Next question, ma'am. Who validates the block? All the participants in the node validates the block. So this is like a running race, ma'am. Like I do a transaction, and after this 10 minutes, say, or for imagination, you would say there is an alarm. This 10-minute alarm is it. Now what will everyone do? Everyone will take the transactions from their memory pool. They start creating the block. And they will start doing this puzzle. Whatever proof of work I told, they will start doing this puzzle. So this will be done by all the people. Because this is a lottery, right? If there are 100 nodes, all the 100 nodes will do. So who validates the block? All the nodes create the block. And if I create the block and send it to all other people validate. Whoever receives this block, they start validating it. This is one thing. And whoever computes that first, they win that, and that block is getting added into the blockchain, they receive the reward. So everyone does the validation, everyone does the computation for the block, but whoever does it first wins, and they receive the block reward. How block size is determined? It is already hard-coded into the code. For example, Satoshi Nakamoto, who created Bitcoin, he hard-coded 1 MB as the maximum block size in Bitcoin. Some people who thought, hey, this is, I think if we increase the block size to 2 MB or 5 MB, then the scalability or the number of transactions will be more. If someone have thought, what they have done is they have forked the Bitcoin and they have changed this size and they have created some other coin with some other name. So there are such things exist. So this is, if to answer simply, it is decided by the designer or the developer who creates the blockchain. Yes, ma'am. As I told, permissioned blockchain is for a private organization or a group of organizations. Say, if East Point College want to create a blockchain system to manage their student records, they can create, which is a permissioned blockchain, where only the students, faculties, and the admin of East Point College will have access to it. Say East Point College of Engineering and Technology only will have access to it. But your college have College of Pharmacy, Business School, and other things, then it is consortium of blockchain. Each of these colleges will have their own blockchain. But if they want to access the other college student records, still they will be able to do it. Then it is a consortium of blockchain. Or if all other colleges, East Point College with some other colleges, they are all joining together to create a blockchain together. That is again a consortium of blockchain, but it will be accessible only by those participants, not by any other external entity. So it is possible for a private use case also, which is the permissioned blockchain. Blockchain is not a security technique. Lot of misinterpretation is that many people are thinking, I want to go to blockchain because of security. Blockchain is not providing security. Blockchain is actually over secure. That is one, personally I see at one bigger disadvantage. Sometimes I quote this example. Security is like you have a house with one door, few windows. You put one security guard in front. That is called security. The kind of security what blockchain provides is there is no door. All the four sides, even the top is sealed. You are sitting inside. So that is blockchain. So this is not security, right? Blockchain is actually more secure. Actually unwantedly secure is what I personally say. So blockchain is not a security tool. So I cannot compare it with any other security technology. It is, as I told, it is a distributed database, but it is not a distributed database alone, because you can write application on top of it. And that application is again distributed in nature. So it is not a security technique. It is not, we cannot compare it with other security techniques. What are the components of blockchain ecosystem? Of course, nodes. Nodes are the major components, because if there are 100 nodes, without these 100 nodes, there is no blockchain. Why? Because if there are, in these 100 nodes only, you have the blockchain, that raw database, and the client which manages the transaction. Okay, so all these 100 system holds the data and they do the computation. So they are the main part. If you look at from physical point of view, from a infrastructure point of view, the nodes. If you look at from the software point of view, the clients that are running, you might have 100 nodes, but at a given point of time, not all the 100 nodes will be available, right? Maybe someone is out of the network because of network partition. Some systems would have got crashed, or maybe I have switched off my system. So only few people will be available. So the client software that is running, and the type of consensus algorithm that they are using to arrive at a decision whether a particular transaction or block is valid or not. So that is another part, the client and the wallet part. So majorly these are the two key components of blockchain ecosystem in general. But if you go to each blockchain, that would differ. Few things will add up and subtract. What could be the complexity of blockchain while a transaction is processing? The complexity, I don't understand what exactly you mean by complexity. What could be the complexity of the blockchain while a transaction is processing? Can you be a bit more clear? Meantime, when I answer the other question, please explain what is the complexity. See, it depends. If you ask which one is good, Bitcoin or Ethereum, see, there is no single answer. It depends upon what you want. Like, this is yellow color shirt, right? I like it. It is not necessarily that you should like it, right? So it is again a personal choice. Each has its own advantage and disadvantage. Bitcoin is a cryptocurrency. So if you're only worried about the cryptocurrency system, then you go for Bitcoin. You want both an application and a cryptocurrency, then you go for Ethereum. Sir, I want to sell my artwork, or I am going to store my, for example, the application I showed, right? Where I was creating a certificate. There is no need for cryptocurrency, right? I created a certificate. There is no need for cryptocurrency, right? So in that case, there is no need for cryptocurrency. So I can go to Hyperledger kind of application where I only worried about the application content. I no need any additional cryptocurrency. So it actually depends upon what is your use case, what is that you want to achieve, what all things you want to achieve, and for that, how much cost you are ready to pay, right? You want to do something similar to Bitcoin, but one Bitcoin is 12 lakh. There is one other cryptocurrency application, say Ramcoin, which is almost forked from Bitcoin, but one Ramcoin is only 10,000 rupees. You will go for this, right? Because it is having almost all the features except one small feature. But one Bitcoin is 12 lakh. One Ramcoin is only 10,000. So you will go for this, right? So it depends upon what you want, what your application demands, and the cost factor, and how much you are ready to, what you want it for auditability, you want it for privacy, or you want it only for security, or you want it for a trustless system. That decides which application to choose. Yeah, smart contracts. Yeah, in the application, in relationship with IoT, yes, smart contracts are more suitable for any place where there are two people are available, two or more people, where they negotiate something that could be written as a digital contract, a digital code, and that we call it. And when it runs on a blockchain, we call it as a smart contract. Okay. In relation to IoT environment, yes, we can use blockchain in IoT, but the problem is, as I told, the puzzles that we are using, like the proof of work consensus algorithm that Bitcoin is using, is highly computational. It requires a very good computing resource. Application specific integrated circuit level of components, GPUs are required in your computer, not normal laptop would be able to mine a Bitcoin transaction. So this computation power is more. But if you take IoT devices or IoT network in general are not that power intensive or computation intensive. The storage capacity is less, the power is less. So these data from the IoT sensors or IoT network have to be again relayed onto some other network for it to be processed and stored onto the blockchain network. Or if it has to be directly used within an IoT system, then we have to adapt blockchain for that. There is a particular technology, distributed ledger technology called IOTA, which is specifically created for IoT kind of network. But that is not working based on blockchain. It is working based on something called as Tangle, 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 which is similar, which is like DAG, directed acyclic graph, right? So it is based on that. It is not blockchain, but it is one of the distributed ledger technology, which a lot of people are trying to use for their own IoT or automotive networks. Even I think Bosch has bought a lot of IOTA coins, I think. Is there a risk while tokens need to be exchanged? Again, what you mean it as a risk? Is there a risk while tokens needs to be exchanged? If it is a similar transaction, what you do, if you, whatever risk you are meaning for blockchain, do you think there is a risk when you transfer money from your SBI account to someone else's ICICI account? Yes, sir. The same risk, what you see there is here. But otherwise, there is no any new risk from a normal point of view. Maybe technical point of view, yes, there could be some risks. How to avoid duplication of data in blockchain? If you you have to write a separate additional layer to avoid duplication on top of blockchain, because blockchain will not avoid duplication. Because blockchain, you give a data, it stores that data immutably. You send a transaction, if the transaction is valid or not, it will check whether the block is valid or not. It will store that block immutably in the blockchain. That's all. And no, it will not allow anyone to tamper it. Duplication, it is not checked. It is not going to check whether this content is already available in the blockchain. That is not checked. Double spending is different from duplication. Double spending is whether this coin is already spent. That is something to do with the ownership, because that is a coin which is treated as an asset. It checks for the ownership. But for the data, there is no ownership. So if you say Ramaguru is good, if once again someone is typing Ramaguru is good, it will not tell, oh, this is already there. It will not check. But if you are meaning this data duplication as I have spent this coin, someone is trying to spend the same coin, it will not allow. Provided that if I am the owner, it will not allow someone to spend. So data duplication is different from data ownership or the asset ownership. How the space assets are managed using blockchain? Ma'am, what is space assets? Do you mean astronomy? It means that kind of space assets, or simple supply chain management? Please give us a scenario where permissionless and permission blockchains are used. See, permissionless is any other system, like for example, your wagon, right? You can go and anyone can go and see the applications, right? You go and give the vehicle number, you will be able to see who is the vehicle owner, right? But some fields will be anonymized. It will be star mark, right? But if you can still go to Parivahan website, you will be able to enter a vehicle number. You will be able to see which state it belongs to, what something you will, but you will not see the complete detail. So any such systems is permission. Good example for a permissionless system. Or if you are going to sell a product, like for example, I am going to issue a certificate, right? This could be a permissionless system because I have issued a certificate. You will not be able to enter some random number, right? Because it is generated in a particular format. So you cannot randomly enter some number and check. So only if the user gives, his certificate ID, you will be able to check. So such kind of systems can be permissionless. Systems where, for example, if you are maintaining your college student record, your internal marks, what is the co-curricular, extracurricular activity, what is the name of a particular student, blood group, all such things, no? Such things could be permissioned. Anything that is to do with within an organization can be permissioned. Why GPUs are used mostly in mining cryptocurrency rather than powerful GPUs? Because GPUs are more powerful than this what so called as powerful GPUs. See, there is something called as ASIC, right? Application specific integrated circuits, right? So each ASICs are created for a particular purpose, right? So for mining, they have created a specific circuit that is getting utilized for mining this. So you are attaching a separate board to your computer which does this mining process. That's all. So there is no, as at least from now, there is no big this thing, because you already have a computer. If you want to make that computer more powerful, maybe you get this ASIC processor and connect it to that. And this is what I know. I'm not an expert in this hardware level and not into mining and all so much. So I am not the right person to comment, but at least from what I know, it is a specific circuit that is created for mining. So people prefer GPUs. Why is blockchain a trusted approach? See, blockchain, if you like, not to confuse you guys, but see, it is, if you look at from a common man point of view, no, it is up to you to trust or not. If you're not going to trust anyone, no, you will not trust blockchain also. Okay. Let us say you saw my screen, right? You saw the application, what I showed, right? So 1 minute, I will again show this. And I can take only another 1 or 2 questions because I have one more session coming up next. So I can take only 1 more or 1 or 2 more questions. So if you look at this, no, okay, when I did this transaction, okay, when I issued the certificate, yeah, it got stored in blockchain. But when I enter this token ID, when I click view certificate, what is the surety that this is coming from blockchain? What if the application developer is taking from some database that he wants the viewer to see? Blockchain is trusted. Okay, I am telling that my application is good. Okay, and this is blockchain based, I am telling. Okay, but as an end user, you will use the front end, right? You are going to, I issue the certificate, this is stored in the blockchain. But what is the surety that when I enter this and click view certificate, how is the end user be so sure that this is from blockchain? This could be from a database, right? The transaction got stored in the blockchain. I am not denying that. But whatever you are viewing when you search, how are you sure that is from blockchain? I can still send it from the database, right? So people can still cheat. If they want to cheat, people can still cheat. So blockchain, we cannot tell it as a trusted environment. Blockchain, as I told, it will not allow you to tamper. If you store 1 + 1 is 2, it will store. If you store 1 + 1 is 95, blockchain will store 1 + 1 95. And when you query it, it will give you that value 1 + 1 is 95. So if you're telling me I trusted blockchain, it is showing me 1 + 1 as 95. If you're seeing this as a trust, then blockchain is not trustworthy. Here the trust means is that it will not allow anyone else to tamper the data, even the creator. So that is one trust. The immutability is one trust factor. Second, if you tamper the blockchain that is available in your computer, only you're tampering your data. There are remaining 99 nodes which is holding the correct data. So that is trust. I don't know whether you meant this as a trust or not, but these are the 2 perspectives of trust I would like to bring up on.
I think that should be a good particular this, Ramaguru. So thank you very much for your time. because the first thing that I wanted people to know is, because the moment they know that of blockchain, they equate it to Bitcoin rather than to the technology behind that particular this. I think it was a good session. So where people could get an idea that what essentially the blockchain is all about. So thank you very much for your time, sir. And surely we will keep connecting with you to see that if, how essentially we can take this relationship forward and build some projects in this application as such. So I look forward to working with you furthermore.
Sure, sir. Sure, sir. Thank you so much for the opportunity, sir. Hope 1 hour is a very short time, or 1.5 hours is still a very short time. So I have just introduced some topics. So if there are any doubts, I am always open to come back, and you can connect to me in LinkedIn. My name is Ramaguru Radhakrishnan only. You can just connect to me in LinkedIn, and you can contact me for any doubts there. I'll be happy to answer there. Thank you so much, sir. Thank you, everyone.
Absolutely. Thank you very much, Ramaguru. Have a great day. Thank you.